Right, good morning, Mr. Simons here. Under this optimization or application of calculus question, and I'm looking at calculus of motion, right? So this is just to introduce you to the basics before you look and attempt the exam questions, right? So let's look at the next slide. So calculus of motion, branch of mathematics that use derivatives and integrals, which you don't do at school, don't ask me why. To study and describe how objects move, especially how their position, velocity, and acceleration change over time. In physics position, we would talk about distance and displacement. Here in maths, we just refer to it as position. Alright, so mathematically, we use S to represent the distance from old school thing. Nowadays, we just use X in physics. So let ST represents the position of an object at time t. So we want the velocity, we want the rate of change of time, or the rate of change of displacement, right? Or distance. So first derivative of position gives me velocity. So first derivative will always give me velocity, and it tells me how fast the object is moving and in what direction. Acceleration is the second derivative, so it's the rate of change of velocity over time, right? So the second derivative of position or first derivative of velocity will always give me acceleration, right? So dv over dt, or second derivative of position over second derivative of time. So it measures how velocity is changing. Say displacement, we look at change in position over time interval. So where it was initially there and where it ended up. So end point minus beginning point. So displacement at time 2 minus displacement at time 1. Alright, so let's look at some basic problems. So say the distance here in the first problem, fallen by a stone, which has been dropped from a building, is given by st equal 4,9 t squared, where t is the time in seconds and st distance in meters. So this is similar to doing vertical projectile motion, right? So first question, determine the average speed at which the stone fell between the second and the 6th second. So average speed, so when we say average speed, we just average there basically just means we're finding gradient. So we want the change in y over the change in x. So first, st there represents my y values, and here, this side here technically is my x. So y in relation to x, so average speed for y at time 6 seconds, what do I get? 4,9 times 6 squared. At 2 seconds, 2 squared, right? So that would give me, at the bottom, my x values is simply 6 minus 2, right? You see there in relation. So there I get 176,4 minus 19,6. If I multiply that out, 6 minus 2 gives me 4. And if I divide by 4, my average speed would then be 39,2 meters per second. Could have also gone and just found the first derivative and said 2 times 4,9 would give me 9,8 t, and then substitute 2 and 16 and then subtract the 2 to get the average speed. Alright, let's look at the next slide. Right, so the distance fallen by a stone which has been dropped from a building is given by st equal 4,9 t squared, where t in seconds is time in seconds and st distance. So to determine the velocity of the stone, so instead of saying speed, say velocity. Remember, speed deals with distance, velocity deals with displacement. But yeah, those are for the physics learners. Those that we all are just doing pure maths, yeah, you can just follow the mathematical process. Right, so of the stone after 2 seconds, right? So after 2 seconds, so velocity first means I must find first derivative. So 2 times 4,9 give me 9,8. 2 minus 1 gives me 1, so therefore t. So after 2 seconds, if I substitute 2 in there, 9,8 times 2 gives me 19,6 meters per second. Right, that's for velocity, right? So you should understand, those of you doing physics, that average gravity, Gravitational acceleration is 9.8 meters per second. Say after 6 seconds, again first derivative, 2 times 4.9 gives me 9.8. 2 minus 1 gives me t. So if I put in 6, 9.8 times 6 gives me 58.8 meters per second. 3. Determine the acceleration of the stone after 2 seconds. So acceleration means I have to find second derivative of displacement or first derivative of velocity. Right, so if we got first derivative was 9.8 t, so second derivative 1 times 9.8 simply becomes 9.8 meters per second squared. So acceleration after 2 seconds stays 9.8. Where I say 7 seconds, t falls away, it stays 9.8. So the stone is accelerating due to gravity, and therefore it's just accelerating at gravitational acceleration of 9.8 meters per second. Right, so I hope you follow. So velocity, first derivative, substitute the value. Acceleration, second derivative, there is no t, so I can't substitute the value. Right, so I hope you follow. Let's look at the next slide. Right, distance fallen by a stone which has been dropped from building is given again by st equal 4.9 t squared, where t is the time in seconds and st distance in meters. Now they say if the stone hits the ground after 15 seconds, it takes 15 seconds for the stone to reach the bottom of the ground. Determine the height of the building the stone was dropped from. So height is directly related to the distance st. So st is 4.9 t squared. So substitute in 15 squared, 2225. 225 times 4.9. So the stone all in all fell 1102.5 meters. The speed at which the stone hits the ground. So when I use the word speed or velocity, I'm required to find first derivative. I hope you follow that. No? So speed and velocity mathematically considered the same thing. Scientifically not, but speed at which stone hits the ground. 4.9 t, first derivative because it's speed. 2 times 4.9 gives me 9.8 t. Right, and it took it 15 seconds to hit the ground, so 9.8 times 15. So by the time it makes contact with the ground, final velocity 147 meters per second. 4.3, we want the acceleration of the stone. So as soon as I use the acceleration, I want the second derivative of distance, or I want the first derivative of speed. So the first derivative was 9.8 t, so my second derivative, 1 comes 9.8, gives me 9.8 meters per second squared. Right, so key takeaways or key concepts we need to understand. If we give you an equation that represents distance and we say we want speed, you need to understand, or velocity, that you're going to use first derivative. Whatever value they give you, you're going to substitute that in. They say acceleration, we're going to find second derivative, and if they gave any value as a variable left, then we will substitute the value and the variable in that. Right, so I hope you follow. If we just say distance traveled or height, etc., then we substitute in the original equation given the value and we find the answer. Right, wish you nothing but the best. God bless. Continue practicing. Your hard work will pay off in the long run. God bless. Bye.